Okay, we're solving equations with complex numbers. This is a very long equation. We have x to the power of 3 minus x squared plus 9x minus 9 equals 0. We have 1, 2, 3, 4 terms. We want to put in a format where we can start to factorize it or factor it and start to find common factors so we can start to find a solution, whether it be real or imaginary. Now, we may be using the formula down here below, which is a sum of two squares. A squared plus b squared equals a minus bi. I imaginary, a plus bi, or maybe another method. But we do want to solve it and find values of x, the solutions or the roots if you want to call them. So I'm looking for something common. We've got 4 terms. Between the first 2 terms, we've got something in common, which is x squared. And the next 2 terms, we've got something in common, which is 9. So let me just factor it using those 2 factors. So let's take x squared out for the first 2 and create a binomial. So x squared bracket inside will be x minus 1, close bracket. Let's try that. X squared times x to the power 1 is x cubed. X squared times 1 is x squared. That's good, and that's minus. That's good. Let's move over here. Let's take a common factor of, between these 2 guys, it looks like 9. Bracket, 9 times what is 9x? Well, that'll be x. 9 times what is negative 9? It will be minus 1 equals 0. Let me try it out again. 9 times x, 9x. 9 times negative 1, negative 9. That's good. You'll notice we have a common factor. We have the x minus 1 and x minus 1. Let me just mark that. That's common to both of them, so we can take that factor out and further factor it by going x minus 1 in brackets again, and take this guy, the x squared, put it there, and the 9, put it there. It's x squared. Remember, it's a plus 9. We can put it in there. So now we're factoring it really well. So that'll be x squared plus 9 equals 0. Okay, now we have factored it quite well. Now we could use the sum of 2 squares here because they're 2 square numbers, the x and the 3, the square root of 9 is 3, bring it down and use that, or we could use a different method for it. And over here the x minus 1 is just x minus 1. We could actually solve that now. X minus 1 and set it to 0 equals 0 because we've got 0 there. That means the solution is x is equal to, add 1 to both sides, the 1 will change sign, it'll be a positive 1. So x equals 1 is one of the solutions, and that's real, not imaginary. Now for this one, we could use this formula down here, and what I'm going to do is I'm going to set a equals x, that's our a, and b, which is the square root of 9, which is a perfect square, let's call it 3. A is x, b is 3. Let's put it in here. So let's start to write that out. So that's going to be x minus 3i and x plus 3i. And that equals 0. Now let's set each one of these to 0. So that means we've got x minus 3i equals 0, x plus 3i equals 0. So let's bring the 3i over to that side. I'm going to add 3i to both sides. That means we've got x is equal to positive 3i. Let's do the same on the other side, but because that's plus, we're going to subtract 3i and subtract 3i from both sides. We're going to have x is equal to, that cancels, we're left with negative 3i. So there we have another 2 solutions. Altogether 3 solutions. X equals 1 is a real solution, and these 2 guys have the imaginary unit, so these 2 guys are imaginary solutions.